Hey there, in this video we are covering the if statement, which is the most basic way you make a decision in C++ or any programming language actually. And this covers sections 4.1 to 4.3 in the Gaddis textbook. So here we are starting chapter 4, which is all about decisions. By the time we're done, we're going to see 3 different ways of making decisions in a C++ program. But the most basic and the most fundamental way you make a decision is always this if statement. Now let's think about why you want to do this. Way back in one of our first lectures, we had this example of, let's say I want to make a check at YouTube for whether someone can make an account there or not. And to be able to make an account there, I think you need to be at least 13 years of age. So we made this test script. It was actually the very first test script we ever made. And we tested, well, if someone puts in an age that's less than 12, the answer ought to be no, you cannot make an account. But if they put in an age that's greater than 13 or up, then the answer should be yes, you can make an account. Now, so far in the course, we haven't actually been able to make a program that did that decision. So that's what we're trying to do here today for the very first time, and how you do that is you use an if statement. Okay, so the overall idea of what's happening here, the technical name is a conditional, which actually covers all the different types of decisions that you can make in C++. So the basic idea of a conditional is we want to be able to perform one of 2 or more actions based on whether a Boolean value is true or false. Remember, we have a Boolean data type in C++, or really any programming language. It's really just one bit, right? It's really whether a bit is on or off, 0 or 1. But we talk about it as being true or false. So that is how you fundamentally make a decision in a program. And here I'm going to start looking at flowcharts. So you want a program structured like this. You start at the top, that black dot at the top. You get to this diamond, which is going to be some kind of decision. That diamond A is going to have a value of either true or false. And if it's true, you're going to take the left-hand branch and take action B, and then go on with the rest of the program to the end. But if question A comes back false, you're going to take the right-hand branch, take action C instead, and then go on with the rest of the program to the end. So this is what we would like to have happen based on a Boolean true or false value. Okay, so before we get into the actual if statement, we should talk a little bit about how do we produce that Boolean value. So a good way of doing that is to use a relational operator, and this should be very familiar with any kind of basic mathematics that you've ever done. Relational operators are operators to test relative ordering. And a relational expression is always evaluated as a Boolean, true or false. And I think we've said this before, that's actually getting stored as the number 1 or 0. But we're going to be talking about the result of a relation as being true or false. And here are the 6 relational operators that exist in C++. There's lesser than, there's greater than, there's lesser than or equal to, there's greater than or equal to, there's is equal to, and there's also not equal to. So on this slide, you see the standard symbols that you would use in a math class to represent each of these relations. Now, not all of those symbols are on a keyboard, right? The lesser than or equal to symbol, the greater than or equal to symbol, the not equal symbol are not actually on the keyboard. So in those cases, we put together 2 symbols together, which really counts as one operator in C++. So, you do the normal thing for lesser or greater, but there is lesser than or equal to. It pretty much literally looks like that. There's greater than or equal to. Notice that for equals, we have to use a double equal sign because we previously used the single equals for assignment. That was already used. So if you want to test whether 2 things are equals in C++, you have to use the double equal sign. You've got to remember that and kind of be careful about that. And then for not equals, you use the exclamation mark equal sign. Generally speaking, the exclamation mark means not in programming. So your relational operators. So keep in mind, the overall idea here is that relational operators compare 2 numbers probably, but come back with a Boolean true or false answer. And we could contrast that with arithmetic operators. Arithmetic operators would be plus, minus, times, divide, stuff like that. And those combine 2 numbers and come back with a number for a result. Relational operators, you're combining 2 numbers and coming back with a Boolean for how they compare, basically. So there's that. I will say, so you got to be careful that the equal sign, the single equal sign in programming means something different than a single equal sign in math. And maybe I've said this before, if I was making my own programming language, I probably wouldn't do it the way it was done in C++. But if you actually want to compare two things for equality, you have to use the double equal symbol. So kind of try to remember that. Okay, so here's a short quiz on those relations that should be familiar from mathematics that are available in C++. So in the examples that appear on this slide, let's assume that the variable x is holding the value 5 all the time. So here's a bunch of relational expressions. It's expressions that has a relational operator in it that you might see in C++. And we'll think about what the value is. The answer's got to be true or false in every single case. And thinking about the first one, right, is x greater than 4? So in our case, that's really, is 5 greater than 4? And of course, that is true. So maybe pause the video and possibly take a piece of paper and write down what you think the answers are for the rest. And when you have those answers, restart the video and we'll see if you agree on the results. Think you're ready? Let's look at the rest. So the second one there, x plus 2 on the left of the relation, well, it's 5 plus 2, which is 7. Is 7 less than 3? That is false. And you can see here that the expression is evaluated, arithmetically on both sides, and the relation is actually done last. So as far as the order of operations go, the arithmetic operators of add, subtract, times, divide are fairly high up, and the relational operators happen even further down in the order of operations than all the math stuff. So for the third one, the left-hand expression, 4 times x, that turns out to be 20. And the right hand, there's that POW function, which is really an exponent. So in this case, it's 5 to the second power, which is 25. Is 20 greater than or equal to 25? Well, that's false. The fourth one down here, the left-hand expression is 5 plus 7 is 12. The right-hand expression, 3 times 5 is 15 minus 3 is 12. Is 12 lesser than or equal to 12? Well, that's true. Specifically, they're equal. That's totally true. The fifth one down, the left obviously 5. The right-hand expression, remember there's the function for absolute value. Well, the absolute value of -5 is 5. So this equality sign is going to be checking, is 5 equal to 5? And that's true. And the last one here, remember that relation is the not equal to symbol. So it's saying, is 5 not equal to 5? Well, that's a false statement because 5 actually is equal to 5. So 5 being not equal to 5 is actually false. So hopefully you got those answers right, and you can see a whole bunch of examples of our relational operators sitting in a relational expression, comparing two numbers, and really coming back with a Boolean true-false value, and that is what they're there for. So remember why we wanted that, right? We wanted that because this is going to be the trigger for an if statement to make a decision about true or false. Are you going to take this action or not? Let's look at that. So here's the if statement, right? It's going to look like this. You're going to see if, you're going to see parentheses with a Boolean expression, probably one of those relations that we were just talking about. And then right after that, there's a statement that's being controlled. So this is how you make a runtime decision in a program. If that Boolean expression in the parentheses is true, then the controlled statement will be executed, will be run, will happen. But if the expression is false, then that statement is just skipped over. And you go on to the next line right after it, and the program runs the way it normally does. Right? Now, in this example here, I'm just showing you one single statement being controlled. If you want a bunch of statements, like 1, 2, 3, 4 statements that are all kind of really one action, what you can do is you can replace that with a block inside curly braces, right? Just like the main function, right? Starts with an open curly brace, ends with a closing one. You can do that for this controlled statement. You can have an open curly brace, however many statements you want really, and then a closing curly brace, and technically that counts as one controlled statement. And that's what that looks like. Now notice that I've got this indented. So when you get into a control block, you get one additional step of indentation. Now, so far, you get into the curly braces of your main function. We've been giving all of those statements one single tab indent to visually indicate that they all belong to the main function. Well, when you get into an if statement, now you get a second tab indent to visually indicate that that stuff belongs to the if statement. So every additional control block that you enter, you get one more tab indent. This if is probably got one tab in front of it, and the controlled statement will have two. And again, we use tab indents for the code in the book and our class. Okay, so let's see an example of an if statement in action. And in just a second, we're going to see a program where someone is computing the average of test scores. And then at the end, they may or may not get a congratulatory message if their average grade is very high. So in flowchart form, the program's happening and it computes an average. And you get to this decision point, and that's where the if statement's going to be. And it's going to check and see whether the average is greater than 95. If that's true, it's going to go take this action of displaying, congratulations, that's a high score. And then it will go on with the rest of the program from there down to the end. But if average being greater than 95 is false, it's going to skip that message and just go on to the end of the program. So here is program 4.2 in the book, which is a pretty good example here. And this program is going to average 3 test scores, like we said. Line 8, it sets up a constant for the threshold of what counts as a high score. You can see high score being set to 95. We have 3 integer variables to get the scores of the tests. We have a double variable called average to get the average. And a little reminder, even if you have integer data like these 3 scores, the average still might come out to be a non-integer, which is to say have a decimal component. So we definitely had to make the average variable a double or some type of float. And there's the data declaration part. And then as usual, ought to be pretty familiar, here comes the user input part where we ask the user, please enter 3 test scores and I'll average them. And they send in the 3 scores there on one line like you can do. Then there's the processing part of the program where we actually compute the average properly. I guess that gets printed out. But really, the interesting thing that is new here in this program is right at the end, right, lines 22, 23 really, is there's the if statement on line 22. It says if average is greater than high score, and there is the controlled line on line 23, and you notice that's an indented one extra tab step that prints out congratulations, that's a high score. So if the average is high enough, you run line 23, but if it's not, you just skip line 23 and you go directly from line 22, jumping down to line 24, and then the program ends without doing any printing. So let's test this program 4.2 out of the Gaddis book. I just grabbed this from our code repository. Our first example of an if statement. Does it compile? Yes, of course. No errors, no warnings. That's what you want. So when a user uses this, they're going to type in 3 test scores, get the average, and possibly print a congratulations message if it's high. So I'm going to want to test this at least twice. I want to make sure that the message does show up for a high score, and I want to make sure the message is skipped for a lower score. So first of all, what could I type in for a high average? Well, what if the user had 90 and 98 and 100? Okay, so it says your average is 96, and congratulations, that's a high score. So currently the program is working correctly. That is what we wanted to see from a high score. But I also want to test and make sure that message is skipped for a lower score. So running it a second time, I don't need to recompile. I'm running the same executable. But what could I type in here that would give a lower score? Well, how about like 60 and 75 and 78? I mean, not terrible, but not super great. So it says your average is 71.0, and you notice that it is skipping the congratulations message. So when this program was running and it got down to line 22, it checked, is average greater than high score? Is 71 greater than 95? That is false. And therefore, it just jumped over line 23. It just skipped line 23, jumped down to line 24, returned out of the program, and the program ended without printing the message. And that's what we wanted. This program is also working correctly in this case. So that confirms that that if statement is doing what we want, and that program is working correctly. Okay, so let's talk about some risks in if statements, things that commonly go wrong, particularly for beginning programmers. So remember, you got to use the double equals to test for equality. Now, a common error at this point is to accidentally have an if statement that just has a single equals in there. And that's going to be a very confusing problem that we'll just think about for a second. Let's say employed is a character variable that holds some kind of character. So if this line were to run, regardless of what was in employed to begin with, whether it was 0 or an n for no or whatever, that's an assignment statement with single equals. It's going to take the character uppercase Y. It's going to overwrite employed. It's going to assign Y into employed, overwrite and change whatever was there before. And the value of this expression, this equality, is going to be whatever you just assigned. Now, for what it's worth, capital Y in ASCII is really the number 89. So employed just became 89. The equality has the value 89, and in Boolean terms in C++, any non-zero value counts as true, and therefore this if statement will always automatically happen no matter what. And what you'd probably get a programmer coming back and go, you know, it doesn't, whatever I type in for input, this if statement just always runs all the time. What's the problem? And the problem is that you accidentally put an assignment statement here, and employed will always become true all the time. Now, C++ lets you do that, okay? It is possible, if you're very, very clever, to structure an if statement in some way that actually works to your advantage. But most of the time, that's a mistake. So I would probably not ever want to see assignments in my if statements. Remember, you got to use double equals for actual comparisons. Remember to use proper indentation. Right? You're in the main function, you get one tab indent. But you get into a control structure like an if statement, and the control statements will now have one additional tab step. Now you'll probably have two. If you're using curly braces for a control block, remember that they should be aligned one above the other for readability. So wherever the if statement started, the closing brace has got to be lined up directly below it. And in fact, probably our IDE is going to highlight that. Right? When you're in an if statement, it's probably going to highlight the beginning and ending curly braces, and they should be lined one above each other for visibility. And when you're testing it now, you need to test each decision branch. So when I test the program, if I have an if statement that either yes or no doesn't happen, I've got to test my program at least twice and confirm that the yes result happens properly and confirm that the no result also happens properly. So I have one single if statement in that example. I had to test it at least 2 times to make sure that both possibilities worked. As you add more control structures, as you add more if statements to your program, that's going to increase combinatorically. So the more if statements you have, you're going to multiply the number of test cases you need to test to confirm that your program is actually working correctly. So let's dig into that just a little bit more about that trigger that makes an if statement happen or not. Remember, in programming, really everything's a number. So we're talking about Booleans being true or false, but yeah, they're really numbers. So in C or C++, most operator expressions, relational operators, arithmetic operators, any kind of symbol you use, are really going to be evaluated as numbers. So for example, the relation 5 lesser than 3 plus 7, obviously that's true. It really comes back internally with the value of 1. 1 being used for true, 0 is what gets used for false. That's probably pretty obvious. Now, if you have an assignment statement, like val equals 6, now 6 goes into val, but in addition, that expression itself has a value of 6 of whatever it got assigned. And you see, that explains that error on the prior slide in the risk of you accidentally putting an assignment statement in an if statement, because then it actually has the value 6, which counts as true, which therefore would make an if statement always happen, which explains that. Now here's a printing statement, right? And you have this left arrow, which is technically called the insertion operator. That's another operator. It's going to have a numerical value. So when you count out hello, this expression, this insertion operator, actually has a numerical value, and it's going to be the memory address of where the count object is in your memory system. And that's actually what allows you to chain a bunch of arrows together on a count statement, because the first one happens and it comes back with the memory address of where count is, okay? And then the next arrow sends the information to that thing, which is totally what you want. And once that arrow is done, it comes back with the memory address of the object, and the next arrow can send more information to that location. And that actually is why chaining together a bunch of arrows on a SYN or a count statement actually works, because it's returning a number, namely the memory address of where this thing is. So every operator actually returns a number, and you kind of have to keep that in mind. Now, in a conditional, right, in the parentheses to an if statement, any value of 0 counts as false again, and any non-zero value counts as true. 1 or 5 or 10 or -15 or a million, anything else other than 0 counts as true. So technically, relations are not required in conditionals. Most of the conditionals, most of the if statements that I write will have relations, but you don't need them there. For example, here's a programmer that got very, very clever. Here's an if statement that does not have a relation in it, and this will compile and this will work perfectly fine. It says if x plus y, count out the sum is non-zero. So let's think about that. If x is 3 and y is 5, well, 3 and 5 add up to 8, and that would count as true, and then you would print out sum is non-zero, and that is correct. The sum, 8, actually is non-zero. That is correct. But if the x was, I don't know, -2, and the y was +2, well, -2 and +2 add up to 0, which would count as false, and then you would not print out the sum is non-zero, which is also correct. Because it isn't non-zero, it actually is 0 in this case. So either way you go, this actually works correctly just based on the number, right, 0 or non-zero in the parentheses for your conditional. I'm not going to do that a lot, but some really cunning programmers might do that once in a while, so just keep in mind relations are not actually required in conditionals. You can just kind of stick some number in there, and then that gets read as either false or true. Everything's a number. Great. So that's the first part of chapter 4, just on the basic if statement and generating the Boolean that triggers the if statement either happening or not, whether you skip that statement or you actually execute that statement and do it. Probably going to use a relational operator to make that happen. It doesn't have to be, but probably for our stuff it will be. So for my students, the next thing we do in person is we do this lab here, where we will just practice with the first if statement. We'll write a test script, of course. We'll try to confirm whether the program's working correctly. If it's not, we'll try to fix it. Maybe the lab file we get falls prey to one of those common risks that we were talking about. And if so, we'd want to try and fix it and make the program actually work correctly. So next time we're going to expand on the if statement. We're going to expand with a second part of it called the else, and you'll have the whole thing is called an if-else statement. And so that'll allow you to take one of two actions, right? Either action B or C, depending on a particular Boolean. So I'll see you then for that.